All right, we're back. We are COMP397 in the fall 2017 semester, and we are week 5, part 1 of our broadcast, and we're talking about collisions. Last week we kind of did the whole motion and everything else with male pilots, and someone said that it's not up online. Let's take a look. It should be. Might not be in order, but I can put it in order. So this is the last week. Here it is, lesson 4, part 1 and part 2. So it's up there. It's published. It just may not be in order, and I'll reorder the playlist later. Okay. All right. So let's go back. We want to talk about a couple things today. If I want to hit our repo that we've been working on, which if you look at Centennial, I've got a couple of things I've pinned to the organization. One of them is the project template you guys are working on, and then we made this male pilot demo from the project, which is we did last week. Okay, so I'm working with this forked demo, right? I may re-upload it later on in its own non-forked version. Okay. Okay, let's continue though, because what I'm working with this week, if you download from there, is this male pilot F2017 right here, right? I'm going to use Visual Studio Code like normal. The Mac has actually been really working hard on trying to get, or Microsoft has been working hard to get Visual Studio to work nicely on a Mac. Still haven't seen a lot of, but it's getting better and better. And it also includes cross-platform mobile app development with Xamarin. But this is Visual Studio Code, and I'm pretty happy with this thing. I'm just going to kind of close some of these things off, right? Actually, if you click this little button here, close them all. And notice last week the way we were working, we had a bunch of assets that we had. That this is our project from last week, and I'm going to launch our terminal. So let me open this in terminal. Now there's terminal here that's integrated with our VS Code, but I prefer to launch it with a separate terminal, right? And with this, of course, I got a CD to the project folder, which is going to be here. You can do the same thing with Windows. And so I'm in the project, right? So you can see it. This is the project that I'm at right now. What I want to do, of course, is as soon as I get here to the project is hit Control-Shift-B on a PC or Command-Shift-B on a Mac, which kicks off my task runner, okay? Because remember, I'm going to be coding, and I want it to transpile automatically on save, right? And if you don't do that, if you forget to do it, you're like, wait a minute, I don't understand why it's not working. It's because it hasn't transpiled. Okay, let's also, in the command line, let's also run light server so we can have that instant feedback, right? When we run stuff. This is what we had last week. We had this. We have this, right? Working nicely. And that's it. Also, by the way, we also had in our inspector, we have in our console, let's refresh this. We have nothing else. There's nothing else going on. We can't detect collisions. So this week, we're going to work on collision detection, and we're going to talk about some methods for collision detection that we're going to use. Okay? So collision detection. What do I mean by that? Well, for those people who've never done games, some of you have, but let's assume that you haven't, right? So for the people that are here who are non-game students, right? I'm going to bring up Fireworks here, and I'm going to load up some assets that we had from last week. One of them was the ocean asset. Here's the ocean, right? And we also had a cloud object, and we also had a plane object, and we also had an island object. I'm bringing these objects in so you can see what they look like in my ocean, right? So here's my ocean. I'll bring that over there, and same thing with my cloud. Just bring them all together so you can see what I'm talking about here. Here we are, and plane, like I'm drawing on the blackboard for you, or the whiteboard here, right? And let's get rid of these things for a second, just to do a cleanup, so I don't have any bad repercussions from doing this stuff. Okay, so there we go. All right, cool. So I want to talk about collisions. So let's talk about this a little bit. So here we are with our objects. Okay, so we've got these objects in space. We don't care about the ocean. We're not colliding with that. But let's suppose that the plane is going to collide with this cloud. Okay, so there's a couple ways we can do it. One of the ways we can use collision is something called axis-aligned bounding boxes. Axis-aligned bounding boxes. So what am I talking about? You have your y-axis and your x-axis, and you take a look at the bounding box that surrounds the sprite for this sprite and this sprite, and if they intersect, you have a collision. Actually, the best way to say is if they overlap. If they overlap, you have a collision. But there's a problem with this method for our game. Why? Because, okay, do I have a visual collision here? Take a look. Do you see that colliding? No. How about a logical collision? Yes, right? And this is a problem. Okay, so that's a problem for us. Same thing with over here. If I take the plane and put it on this side, there's no collision. You can see clearly that there's, in the game, you won't be able to see a collision here, but logically, you can see that the plane lies within the bounding box of the cloud, and that would be an issue. Not so much so with the island. The island's kind of squarish, and so if the plane hits the island, who cares? Because it's so square. Even if I come here, you know, it's so close, you probably will hit anyway, even here, right? Because they're the same size. But here, when there's a discrepancy of size where the plane can escape, and you can have the user clearly see that there's no visual collision, you could have a situation where you have a collision. So the other problem with this system, when we do this collision detection, this version of collision detection, no. Hold on a second, not the right one. The other problem we do it this way is, if you look at it, I'm going to have to do a check. And I'm going to check for each object. So I'm going to check if there's a collision between the plane and the cloud, between the plane and the ocean. And I'm going to do this every frame. Every single frame that passes, which means every 16 milliseconds, I'm checking to see if collisions for the plane and the cloud. Now, of something called broad phase and narrow phase collision detection. So broad phase means when the objects are far apart, don't check for specific object collision, because you just know that the plane is at a certain point in time. This can be accomplished very simply, like, well, if these objects aren't low enough on the screen, then there's no possibility of collisions, so don't check. Okay? But that is a check. For you to check that there's no possibility for a check, it's still a check. Okay? You're checking. You're branching. You're saying if, right? So just a moment. I'm getting beamed by the powers that be. That's my wife, right? And she's gonna, yes. So one word answer: yes, no, right? It's a thing. It's a trick for women, right? They go crazy. So I'm just joking. I'm joking. Right? Yes, no, yes, right? Anyway, so so when you look at this thing, right? We're talking about collisions. There's a couple ways we can approach this. So some people might say, well, if we do broad phase collision detection first, that saves CPU cycles, because I don't have to do the actual math. There's math involved to see if I'm colliding, other checks. And it's a very much lighter way of checking. However, what you're going to see is this. When these objects here are way far away, then the game is going to run really fast, right? And when the object starts getting close, let's say, for example, there's a line, I start saying, well, if anyone goes below this line, right, then start checking collisions. Right, as an example, right? Okay, but that means that I'm going to get computationally crazy after about this point, right? I'm going to say, well, okay, here's the line. When you cross this line, that's it. I'm going to start checking for collisions. So when I come to here, all of a sudden the whole game was going to slow down, right? Because now I'm doing narrow phase collision, right? And narrow phase collision, I'm checking individually to see if I'm colliding with every shape, right? Now, in a simple game like ours, it won't matter because we only have a few objects. But in a game where you have thousands of objects or particles, or if you're doing a hell, kind of a shooter hell kind of game or whatever, it could matter, right? It could make a difference. It really depends on the way you set up your methods and how efficient you are doing stuff. And there's other ways to do this a little simply. So my advice to you for this game is do narrow phase collision all the time, right? And why is that? That means you'll have crappy performance throughout the entire game, but it'll be the same crappy performance all the time. You won't go really good performance and then crappy performance, because that's really bad, because you'll notice it. Even if you, in broad phase, you did like, oh, this is really good performance. And even if it drops only a little bit, that little bit enough will be enough to say, hey, look, it's slowing down as the objects get closer to me, which always sucks, okay? So don't do that. I recommend doing narrow phase collision. Okay, now let's also take a look at this. How do I do it then if it's not bounding boxes? Well, there's some other options too. For example, you could use something called separated axis theorem. Separated axis theorem, what it does is says, well, okay, so I have these objects. Like, this is okay when the axis aligned, but what happens if this is turned? Like, for example, I don't know, somehow I have a game where my actual object is turned this way, right? Look what happened to my bounding box. My bounding box actually changed shape. That's bad, again, because now the bounding box is not the same shape as it used to be. Same thing with the cloud. Like, if the cloud changes shape, like what happens when this happens? Like, so I have this cloud, and then, it's changed shape, right? So now my clouds object is like this, right? Which might cause me to have a different calculation issue. Like, if I'm passing the plane this way, you can see I'm not colliding, but I'm colliding. Well, what they can also do is something called separated axis theorem. So for each face, I'm going to create my bounding box, and for each face, each normal, the face that points away from in each direction, I'm going to do checks. And it's like axis aligned bounding boxes, but what I'm doing is I'm checking that, make sure that there's got to be at least two faces that don't have a collision between me and the other object. And it's much closer to what it would be to see that I'm colliding or not. Again, very computationally expensive, but more accurate. Here's what we don't want to do. We do not want to do pixel perfect collision ever, right? Unless you're doing a graphics simulation, like some kind of physics simulation where you're actually having to know because it's not a game, you're making it for physics or some kind of research project, right? It's just too intense right now for our processors. It takes too much time for you to do this idea of pixel perfect collision. You don't want to do that. You'd rather do something that is good enough. So what's good enough that I recommend for 2D games? Maybe not for 3D games. For 3D games, maybe we'll use broad phase and narrow phase collision, right? Because the shapes can be very complex anyway, right? So performance overall for 3D games may not be affected, especially when you're using a console or something. You won't see the difference, and you'll be actually saving yourself cycles. Actually, overall, the performance will stay good. 3D games, especially on the web, making axis aligned bounding boxes work yes, they'll work, but it won't look good, right? And it'll be working faster than my system, but it won't be as accurate. And you want to kind of have a balance. And this is the system that I'm going to use. Distances. So I'm going to find almost like I'm defining almost a radius for every object approximately, or height and width. And I'm comparing the relative heights or widths of the two objects compared to the distance in between the centers of the object. So there's the center of the object, the center of mass, and then between the center of mass and my object, if the distance is less than half the heights or half the widths, a collision. Because that means that distance between the two objects is less than half the height of the objects, they're colliding, right? And it's fairly accurate. Where it gets hairy is where you have objects that are really long, really short, like really narrow, you know, those kind of things. Those objects kind of, you have to think of other ways of colliding. And sometimes what we use is more than one collision detection system, like broad phase, narrow phase, and then different levels of collision to make sure that you have good collisions. Also, the other thing that you want to think about when it comes to collisions with 2D and 3D objects is the tunneling effect of bullets. So you have a bullet, fires, it's very small. Like imagine if this is a bullet now, it's not a plane. And here's the shape that I'm going. And every frame, my bullet moves X number of pixels. So this is the first frame. I check. This is the second frame. I check. If it's moving this slow, I'm good. This is the third frame or my fourth frame. I check. I'm colliding, right? That's what happens. But what if the bullet's moving very fast? Here's the first frame. I check. Here's the second frame. I check. No collision, right? Because it skipped it, right? Went through. So we have to do predictive where it's going to be, right? Kind of analysis, right? And that becomes more complex with bullets because you have to kind of think about it. Sometimes what happens is, along with the bullet, we also put some other box that's invisible, like something like this, right? Where you know that if this box much longer than the actual object is here, then you know what? We can figure out from the shape of the object where it's going to be, that it's going to be a collision, this next frame, no matter what happens, right? And then you can do damage and all this other stuff, right? Otherwise, it just goes straight through. It'll look like, hey, that should have been a collision, but it went right through because too fast. So here's the tricks for you. The smaller the objects are and the faster the objects are, the higher the chance they're going to tunnel through, right? The larger the objects are and the slower the objects are, they're going to be a nice collision, right? You need to find that balance. And when it comes to gameplay, you need to figure that out. There needs to be some kind of way of doing that. By the way, I'm not talking other methods like dot product, right? That's another way of finding out if you can use dot product and matrices to figure out if there's a collision as well, right? But we're not going to go there for now. Let's, for us, without math, not too much math, figure out the distances, right? And that's what I'm going to be using. So let's go back to our game. How do we apply this stuff in code? Well, let's see what we know. Inside of my core, I have my game. In my game, last week, we talked about using this state machine to shift between scenes. So if I'm going to do any collision detection, it's going to be inside my play scene. Definitely not in my start scene. Definitely not in my end scene, right? My play scene is where all the fun is going to be. Okay, so let's take a look at my play scene. Here's my play scene. Cool. All right, well, let's see what I do here. I set up my plane, my ocean, my island, and my cloud array. I define a cloud number, and then I have my asset manager, my current scene. And what ends up happening is I initialize or instantiate plane, ocean, island, and all the cloud objects, the cloud array, right? And inside my update, I update everything, all the positions, rotations, scaling, everything else that's happening, speed, translations, everything's happening in my update function. And in my main functions, when I add objects to the scene. So that's all I've done. Okay, so I need a system when, during update, I can check to see if my plane collides with any other object. There's two objects I can collide with. I can collide with my island or a cloud. Let's do the island collision first, right? Now, I'm going to write it as if it's a method. And then later, we'll think about making it a collision manager, right? So it doesn't have to be, it won't be just for one type of thing. It'll be for everything. For now, though, let's make it work. There's two ways to do this. You work perfectly and never get things done, or you work and then revise after. Both ways have its disadvantages and advantages, right? Like, for example, if you're a meticulous person when you code and you're like, no, we can't do this. There's going to be rework, right? You might never get her done on time, right? But if you're the other person who's like, don't worry, we'll brute force it and make it work. That's the other extreme, right? Then you'll work, but it'll work like crap and it'll be efficient, right? There's these two I'm telling you right now, there's these two camps, right? So somewhere between, we'll try and get it somewhat efficient. Doesn't have to be perfect, but it needs to work as fast as possible. Okay? And then we'll revise afterwards. Okay, so in our update, I'm going to create another method down here. So here's our main method, right? And that's under here. And what I'm going to do is just underneath the main method, and again, in my code, it's around line 59. I'm going to create a new public method, right, called check collision. I'm making it, actually, let's make it private because it makes more sense to be private. Check collision. Okay. Well, I want to be able to check collision with different objects. So I'm going to probably have to pass the object in here, right, to check the collision with. Wait a minute. Hold on. I've got my island object and I've got my cloud object. But when I look at my objects, my cloud, right, is of type bitmap, right? And my island is of type bitmap. I could check to see if bitmaps are colliding, right? But wouldn't it be nice if we had our own game object class, right, that had some of this stupid duplication taken out? I think it's time, because we're going to encounter a problem now, right, with this stuff. Because a bitmap does not have width, height, half width, and half height. It doesn't have that. Only my islands and my clouds have that stuff right now. But they're two different kinds of objects, right? An island and a cloud. I want to be able to access the same methods and same properties on both objects. So I need some other kind of object to be a superclass. So let's make, under the objects, I'll make a new file. We're going to call it game object. This game object is going to be very similar to either island or cloud. We're going to take the cloud object as a template. So we're going to go to cloud because it's the most complete object. I'm going to copy everything. So copy everything here, go back to my gameObject.ts file and paste everything in and rename it. Instead of cloud, I'm going to call this game object. Now my game object will extend the bitmap for now. Later on, we'll make it extend sprite. We'll talk about that later, right? But guess what I need? I need width, I need a height, I need half width, I need half height. These are all good things to have. I have some private properties called vertical speed and horizontal speed. And these things may not stay as private properties anymore, right? Because I'm going to inherit them, and I want to have access to these. Now, there is another one that we use very rarely. What's the other access modifier type we could use in code, right, in C# or something else? We have private, we have public, and protected. And we don't want to use that too often. But here might be a good case for it, because I'm making a superclass, an abstract class, and I want my other subclasses to be able to use this kind of private vertical speed and horizontal speed, but I don't want that to show outside of my classes. So it's kind of a hybrid. Now there's other ways to accomplish the same thing. For example, I could use interfaces. I could use other structures. Let's just make these protected. So just change the private to protected. Same thing here. In my constructor, I'm taking my asset manager, I'm passing it through. However, it's not always going to be cloud. It might be island. It might be cloud, right? So let's, in my constructor, take in another variable called the asset string, right? Or you could just call it whatever the asset is called, the image string. That's what it is, right? So in here, I'm just going to call it image string, and it's of type string. And instead of my cloud going in here, hard coding my cloud, I'm just going to put in here the image string. Okay, so that gets passed in. So far, so good. I'm keeping all this stuff in my game object, by the way. All right, let's see this. In my reset method, it says, well, I'm going to take this and reset the height. That works for cloud and island. Math.random for X. Okay, this is cool. This can't be in stuff. That can't be. This is all individual, this reset method. And by the way, it's private. I need to make it protected for now. We're going to see if there's other ways of doing this. But inside here, this can't be. Gotta get rid of it because it's going to be different implementations for this thing than anything else. Same thing with my check bounds. That's also going to be different implementations, right? Because right now I'm checking for if this is greater than 480 plus the height. It's close. Maybe I'll use almost the exact same code for my objects, right? But this might have to be implemented differently for different objects. So again, I'm just going to leave this blank. My start method. This, my friends, this cannot be implemented, anything less than this, right? This makes sense. Start here would have all this stuff, but oh my God, I may have to override it or add to it somehow. Maybe, is there something else by keeping, I want to keep the start and update methods, but is there something else I can do with this? And I think there is. I'm going to make another method called Initialize that does all this stuff that I can call within my start method. But I'll leave my start method blank. Go here. I'm going to call this a protected, I don't have this yet, function called Initialize. I'm just preparing right now, which returns void. And I'm going to take all this stuff here and pump it into here. Because all this stuff is good, right? Regx, reg-y, blah, blah, blah. These are good things, right? I don't have to do these calculations ever again. Oh, it'll be part of my everyone who uses or any object that inherits from game object will have all this stuff happen automatically, right? Now remember, some of this, like regx and reg-y, you can make switches to turn them on and off if you want to. We'll leave them as is. In my start method, I don't want to call my reset. I want my function or my class to implement the start method by itself. And same thing goes with this stuff. So I got start, update. I've got initialize that everything has. I've got my protected, reset, and check bounds method. Curious. For my reset and check bounds method, should I even put them in? They're empty and they're protected. They're never going to be used by anything. And they're going to be reset and rewritten anyway. And I'm never going to check for them. So we can leave them out. The only protected method so far is this one. Okay, let's keep backtracking. Okay, vertical speed and horizontal speed. Am I going to have vertical speed and horizontal speed for every object? If yes, then maybe you want to think about making these public, right? Vertical speed and horizontal speed, and remove the protected. Protected, remember what we talked about in C#, if you guys were with me? Sparingly, almost never. It's bad form to use protected as much as possible because it's kind of in the middle state between public and private. Why? There's got to be a good reason. You have to work around a problem for you to use protected, right? So for now, I'm going to make these public and these public. Vertical speed to vertical speed, and make these public and make sure it's explicitly public inside of here, like this. I don't like when that happens. I meant to do this. Save myself some time. I probably spend more time doing that than actually typing. All right, there we go. Public. On that, here's my initialize method, right? It's protected. If I made it private, would I be able to access it from my child class? I'm asking. Would I be able to ask can I access, if I made this private, would I ever be able to call this method from my child class? No. No. But I know I'm always going to want to call this method, always. So let's make it private. Hear me out, right? And instead of it being called in the start method by default, right? Because we shouldn't do that. Let's call this underscore initialize here every time in the constructor, right? So in the superclass constructor, I'm always going to call the initialize method, which does all of this. I'm still going to have my start and my update methods, and I've gotten rid of all those pesky protecteds, which I don't want to use. But I started off very high, having everything inside my class, and now this is bare bones what I need to carry along with everything else. Okay, cool. Now, we just created a new object. We need to make some changes to our code. The second thing I need to do after I make my object is I'm going to go down into my index.html and add it in. Now, because it's the superclass of all the other game objects, maybe even of plane and ocean and island and cloud, maybe even of label and button. I don't know yet, because some of this stuff, especially button is a bitmap. So I could potentially use it for everything, right? For now, I'm just going to put it before everything else. I'm going to copy this and put it here. And it's going to be objects, and it's going to be called game object, right? Game object. Cool. So I've got my game object. It's linked to my files, right? I need to put it up on GitHub. I made a new change. I made this thing happen. Let's make sure that my play isn't going to change. My play scene, I just made this object called check collision. I'm not doing anything there yet. I've got all these changes. I've made my new game object. I modified some of these, but who cares? But these two changes, index and my game object, have to be added to the staging area. And I'm going to say added game object superclass. Push. All right. This is very similar to what we did with the scene object. Hey, TypeScript, do you have an abstract class? Because that's what we're doing. I'm never going to instantiate an object of type game object. I'm going to use game object as a blueprint for other game objects. It's an abstract class, right? Does TypeScript have abstract classes? Let's take a look. So TypeScript, lang.org. We're using that language as a syntactic sugar, right? That's what we're doing. Wow, TypeScript is updated 2.5. I wonder what they've added in. Let's take a look now. So if I go to handbook on TypeScriptLang.org, right? And if I look at classes, then you can see that I have examples of classes, right? Here's my class animal, private, public, and protected modifiers if I want them, right? Here they are. Nice, nice. Read-only modifiers. That's interesting to have that. Cool, cool. Accessors. Get and set accessors. That's all part of the stuff. Static properties if I want them to. We'll use that one time. Hey, that's what I wanted. Abstract classes. The abstract keyword. Okay, but what does this do? Notice that it says abstract classes are base classes. They may not be instantiated directly. Unlike an interface, an abstract class may contain implementation details for its members. The abstract keyword is used to define abstract classes as well as abstract methods. So let's go back to that game object. I could change this from a class to an abstract class, right? But these two methods, start and update, could be abstract methods that need to be without implementation details because they're empty, right? So notice that it is abstract. And if I hover over, it says method start cannot have an implement action because it is marked as abstract. So let's get rid of all this stuff, right? Same thing goes with this one. I'm just showing you that this is possible to keep this class nice and low, right? I got some properties. Well, they're actually instance variables. I haven't talked about properties yet. Okay. So if I really want to be crazy and I want to go into the super duper way of doing things, I could use getters and setters. For now, we're going to skip that piece. I will come back to optimization later. Remember? Balance between otherwise we're not going to get this done today, right? So I can be fooling around with classes and objects and teaching you TypeScript all day. And it's not going to, we're not going to move the game forward. And your game design documents due tonight. We have to move on. That's enough. This abstract thing, this implementation, what else we need to know? Well, when we use it, here's my abstract class. We might have some abstract methods, right, as an example. And notice that it has this class, accounting department, extends department, this example. And we have an abstract print meeting. And now notice that I am just overriding my print meeting. But it's going to force me to have in my class, this case, in our case, and a start method. It's going to force us, right? It won't allow you to implement a class like that without it. Okay, I'm going to leave this alone for now. And I'm going to go back. So this is good. And we may want to modify later on, not now, our scene class to be abstract as well. Okay, cool. So this is good. This is a template. Now, how do I modify it? How do I use it? Well, let's go back. I know that my cloud class is not going to extend bitmap anymore. It's going to extend game object. So it's going to be objects.gameObject. That's what it's going to extend. Uh-oh, look at this. We've got a problem with a constructor, and we're declaring all this crap that's already been declared, right? So we can get rid of it. You're going to see that our classes become a little bit cleaner now. And all I want to do when I implement my abstract class is run it and test it, okay? Because I don't want to do this. So now, my constructor takes the create.js load queue, right? Okay, when I pass it to my super constructor, I also need to pass this through, right? So it's got to be my asset manager has to be pulled through inside of there, plus my get result, right? So let's see what the abstract class needs. So in my constructor, I take an asset manager. Okay, that's all I need. Let's go back here. I need the asset manager, right? And the image string. That's what I need here at this point, right? So I pass the asset manager through. And the image string, which is going to be, in this particular case, cloud. Right? That's what it needs. And to make sure that that's correct, just a reminder, recall that when I go here, that these are the names of all of our assets in our game.ts file for now. So here's our cloud. Okay, we're still got errors. Why? Because we made these public. I just have to keep track of them. So I can get rid of the underscore because they exist. And here. Does anything else change? Let's take a look. Is there anything else that I'm declaring like this? This doesn't have to be here anymore. Get rid of it. Now, it's a lot lighter because I've already got that in my superclass, right, for cloud. Let's do the same thing for island, because that island has to change too. So island, and now it doesn't override this one, doesn't inherit from this one, it inherits from objects.gameObjects. And again, we're going to pass in a reference to the asset manager as well as island, right, the name of the image. Cool. I don't have to do any of this. Well, I need to do this. That's for sure. because that's different than the other implementations, right? But all this doesn't have to happen. All this stuff here is already done. Okay, this stuff remains, check bounds remains, reset remains. All that stuff is normal, right? This stuff can go, right? This stuff can all go because it's already been done. And that means that my vertical speed down here has to change to vertical speed. Okay? And now it's a much cleaner and easier to understand implementation. Just to say, I have to be honest and tell you this, right? Our plane object can be also a game object. And so can our ocean object. So can everything else. But remember, all we care about is the other game object right now. We don't care about that our plane and our other game objects are the same yet. We may need to do that later because we're duplicating. There's lots of duplication in our in our plane, which is very similar. But remember we talked about this? We're trying to get things done, right? We're not going to do everything, only the things we need. Minimum viable product, right? And then we go back and make it better. Okay. Let's check to see if everything works the same way right now with the changes you made. Right? So if it works, we should be able to see it right here. Right? Because if it doesn't work, we'll have an error. Let's make sure we save everything. So save all in code. And we go back here, and if I refresh, still good. Start, still good. Right? How do I know? Because if I go back to sources, and if I go back to scripts, and if I go to objects, if I see a game object type, here it is. And if I see that my cloud object, right, is of type game object, which I do see here in the online, I know that I'm good. Right? I'm telling you this because this is the best way to check online. You know that this is being implemented. If it showed the other stuff, you know something's wrong. Didn't get compiled or something. And this is giving you a false truth. Right? But here it works. We know it works. All right. Now that I've done that, let's go back to this. I know that my island and my cloud are both they're both game object types, right? Which means I can compare for game objects. How? If I go back to my place scene, in my check collision, I want to get the other object. The other object is going to be of type objects.gameObject, right? They have all the same properties, right? So I can check to see if they have, you know, what I'm looking at, the distance between the objects and all those kind of things, right? I know that each of my objects have a position, an X and Y coordinate, right? And if you look at the Create.js, Easel.js documentation, right? If I go Easel.js docs, here they are, right? Here from something called display object, right? So if you look at my bitmap, it inherits from display object, right? And in the index of properties, these are all the things it has. All of them have this built in, all display objects, which means because bitmap is a type display object, then objects.gameObject is also a display object, right? It has all this stuff. Red X, red Y, rotation, shadows, my image, my filters, my hit area, all this stuff that it has, right? I'm not going to use hit area because that's pixel perfect, right? We won't do that right now. But it has the other stuff, snap to pixel, stage, all this stuff. Because it's a display object, it has all this stuff inside of it. And all these methods have been inherited, right? Set bounds, my update cache. But what about my X and Y coordinates? Well, here they are, X and Y, right? I also have something called transform matrix. I'm just putting it out there, guys. I'm not going to use it right now, but I'm putting it out there for those math types out there. Love math, right? I have a transformation matrix, right? And notice I can also set transform. Set transform gives me something that we've already kind of did, X and Y and scale X and scale Y, rotation and skew, and all this kind of stuff it can do. So I can set transform of my object anytime I want. These are things that clues that we're going to use for later on, right? Of what we can possibly do. And we also have in my index of method something called this, like I said, this because it's a display object, I have this transform matrix. And the transform matrix, it says if set the transformation for this display object overriding all transformation properties X, Y, rotation, scale, and skew. Right? And what it is, it's inherited from display object transform matrix. That's what it is. That's what it inherits from. And there's the code. If you want to see the transform matrix, right? It's inside the display object, right? And what it does is it sets up a matrix that has scale X, scale Y, rotation, all this stuff. You can see this is right in the code itself. Why am I telling you this? Because you may decide later on that, you know, some of the stuff we're doing, you can optimize. If you're an optimization person, right? I'm just pointing to the people in the back, right? Because I know you people, right? There's ways of optimizing without doing what we're going to do now, right? But what I'm going to do is I'm going to set up a new object called a vector2 or a point. We know that, actually position. We know that all objects have X and Y coordinates. But I want to be able to quickly know the position from one point to the other and the distance between points, right? The position is going to be X and Y coordinates based on the reg X and reg Y, right? So if we have a point class, EaselJS has some helper class called the point class. Here's the point class. And the point class does exactly that. It gives us X and Y in a small little class, right? So we can use it by using createjs.point, a new createjs.point. Think about this as a vector2, right? In most, if you're making games, a vector2 is X and Y, a vector3, X, Y, and Z, vector 4, X, Y, Z, and W, right? And where W would mean the imaginary number for the transformation matrix that you're going to use when using things like quaternion motion and all that stuff, all right? We're not going to use that right now. All we care about is X and Y. A point class, which really should be named vector. That's what it really is. And if later on we'll use it as a vector class, for now, we're just going to leave it because minimum viable product says point. We're going to keep it. It's already been created for us. We're going to use it. So that means that in my game object, because I want to keep track of positions, because I'm going to compare positions with my distance formula, I want to know the position of an object, right? Which means I need to create it. So inside my abstract class, right, I'm going to have something called position. It's going to be public. Okay, position. And it's going to be of type createjs.point. Okay. So all objects will have, all my game objects will have my game object name dot position. Okay. This is all prep. All prep. We're going to need this later on. Okay, like I talked about. In my initialize method, I'm going to set up my position, right? Right at the end. I'm going to say that this dot position is equal to, this dot is equal to a new, right? I have to make a new createjs, createjs dot point object. I'm going to passing in this dot X and this dot Y. So now I know my initial position. What's my initial position? 0, right? 0, 0, my initial position. So this initializes it. But what I want to do is every time I move my object left and right, or whatever it's going to be, I want to update my position. I want to keep that in mind when I do that, because if I update my position, I don't have to do it later, right? This is going to be done in my update method somewhere. Won't be done here because it's not implementation, right? But somewhere else inside my cloud and my island classes, I want to update my position every frame. And this is where I'm going to do it. Here's my cloud. Here's the example of my cloud. And my cloud object, I'm going to go this.position, right? And I want to say it, right, is equal to what? A new create.js point, right? There's one way of doing it. And you put in the x and y, this.x and this.y. That's one way of doing it. What's the other way of doing it? Well, position itself also has x and y coordinates. So I can say position x is equal to this.x, but it's going to require 2 lines, right? So it's better, but if I do it the other way, I'm instantiating an object every frame. So this might be easier, this.x. This.position.y is equal to this.y, right? All right, but take a look at what I'm doing here. Remember I told you that every method has one purpose. I'm updating and checking bounds. Guess what this needs? This needs a method. So I'm going to take this stuff and I want to create a new method from this, right? Wow, you're really sick, eh? Glad you showed up today, though. So my new method name will be, right, update position. It's going to be a private method. Private update position method. My update position method is going to do all this. And then this _update position. It's much cleaner than doing it all inside the update method. Okay? That makes sense to you? I'm just restructuring a little bit, not too much. I know I've spent some time doing this, but this is all prep for my collision system. Right? Okay, cool. Let's do the same thing with my island class. Okay, I got my vertical speed, but I also want to keep track of my position. So I guess what I'm going to do, I'm going to go back to my cloud. I'm going to copy this thing right here. I put it in my island. Now, if I do enough of these copies, I know that this is something I want to do all the time, and I put this inside my super constructor, super class, my abstract class, if I do it all the time. But I won't be implementing this function the same every single time. But for example, I don't care about the x position, right? In this implementation, so I can take this out. But I will do this. This _update position. All right, so I kind of done this twice. This is neat. And now I keep track of position. What other things do I need? Here's another thing I need. In my abstract class, I'm going to check to see if my object is colliding all the time. Because what if I collide, going back to the example that I showed you with the plane and the island, if I have my plane and I have my island, and if I'm checking every single frame as my plane passes my island, I'm going to collide multiple times, right? It's going to check for collision to see if is this one inside this one. Yes, 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 yes. It's going to keep checking a bunch of times, which means I'm going to register multiple collisions. That means I'm going to have to turn on to say, am I colliding? Yes. Don't register any more collisions, please. Just one. If I'm not colliding, now start registering collisions again, right? Otherwise, you're going to get sounds like this. If I make a bing sound for a pickup, it's going to go bing, 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 bing 5 times, but when I pass through, and I don't want that. Okay, so if that's the case, going back to my abstract class, I'm just building this abstract class up a little bit more, making it a little fatter, right? I'm going to build up another public variable called is colliding, and which is going to be of type Boolean. Right? That's the second one I've added. This is to support I'm supporting my collision system. And inside my initialize method, I'm going to register that it's not colliding by default. So I'm going to say this dot is colliding is equal to false. Because at the beginning, we're not colliding. One more thing. I feel like Steve Jobs. One more thing. I wish I was Steve Jobs in some ways, right? Thanksgiving. Let's go back. Would be nice if we knew the name of the object, right? I can identify it's a cloud or whatever I want, but it'd be nice if the objects had names. The object had strings that associate themselves, right? Now, by default, this is the great thing. If I go back to this stuff up here, I can see that in my index, right? Let's go back to my bitmap for a second. This is what I'm basing it on bitmap, right? In my bitmap, in my index, I have a bunch of stuff, right? Here's my methods, and here's my property. Well, guess what? I had a name right there. It's already built in. It says an optional name for the display object, included in toString, useful for debugging, also useful for us people, right? So we don't have to do a name. The name is already there, right? Just FYI, which means that inside my initialize method, inside my game object, I'm going to set my name, right? So I'm going to set it to an empty string just to make sure. This dot name is equal to empty. Remind me that I need to use the name to check to see which one it is. Okay, cool. Now let's go back to my cloud. In my cloud method, right? In my start method, I'm going to set the name. This dot name, right, is equal to cloud. Hey, question for you lovely people, right? So I have to do it here. Am I not passing the name of my object into my superconstructor every single time? Yes, I am. It's the name of my image string. So this is nice, but I just figured out that I don't have to use it here. In fact, going back to my game object, I don't have to do it here. I can do it here. Because in my constructor, I can say this dot name is equal to the image string, which comes in from the other thing, right? So I already have it. Once I put a cloud in there, I know what it is. Here's my image string right here, right? So now I know the name of the object. I can differentiate it. Is it a cloud? Is it an island, right? So I can tell which one I'm colliding with now, okay? This is before I even do collisions. Fantastic. I've updated my game object. I'm ready. Woohoo! That took a while. But guys, when you write a game engine from scratch, that's what it takes. It takes a little bit more planning and thinking. And by the way, I've done all these errors before. I've gone along the way. I made mistakes. Eddie and I saw some mistakes last week when we did the game object in Unity, right? And it keeps happening. You know, we get better at coding and we remember how we do stuff. Okay, so now in my play.ts, this is where I want to do my check collisions finally, right? So this is how it's going to be. I want to say that if my game object and my plane, my plane position, man, I guess I could set up points for my plane position. I want a minimum viable product time. I don't want to bring my plane into my game object class. It's going to be too many changes to do that. Let's go back. So I'm going to say these two variables. So here's the first variable. Let P1 or point 1, right, is equal to a new create.point. Hear me out why I'm doing this. I don't like using P1 and P2, but this is a great case for it. Okay? And the point is going to be actually is going to be my this plane itself, because my plane itself, so plane, remember plane? The plane object? This dot plane, it has X and Y coordinates. So I'll say this dot plane dot X and this dot plane dot y. So that is P1, right? And let P2 be equal to the other game object, right? Dot position. Why can I do that? Because position and P1 are both of type point. And I'm going to type them right here to make sure. So in P1, I'm going to call this a createJS.point. Later on, we'll make it a vector too. And P2 is also going to be of type createJS.point. Right? So P1 and P2. Point 1 and P2. Point 1, point 2. Okay, if I want to find the distance between 2 points, right, I need to use a couple ways. Rise over run. Could use gradients to figure it out. Math, or the classic Pythagorean theorem, right? A squared plus B squared is equal to C squared. Uh-oh. Holy crap. I need to use square root every 16 milliseconds. Square root is a bad function to use every 16 milliseconds. It's always be able to, I'm just telling you, it is. It's a bad function because it's pretty heavy, right? And I need to have this distance. I need to calculate the distance. I don't have any way of calculating the distance. There is no distance formula that's built into JavaScript. Okay, future note. In my backlog, right? I need to make a vector class. It's going to be an extension of createJS.point, and it's going to include a distance method that calculates the distance between 2 points. It's going to be static, so I can call it from anywhere. Make sense? Not going to do it now. For now, I'm going to calculate it really ugly and heavy inside my my check collision method, right? It's going to be long, so watch it, all right? And I'm going to keep the crazy square root right now, and I'm going to figure out how to simplify the square root later on. How do I simplify square root? I just leave it as squares. I leave it as squares. Hear me out, right? If I leave it as squares, right? If I take a squared plus b squared is equal to c squared, right? And if the distance is c squared, I'm going to get whatever that would be for the square root. That's going to be fine. So I can compare the distance as twice. It's the square of the distance, right? So what do I got to do to the difference between heights? I got to square that. Square the heights, square the distance, no square root, right? We're not going to do that today. We'll do it another day. How do we do this? We're going to say if. Here's the long if statement. Ready? If P1, right? If math, so capital M for math, dot square root, right? Math dot square root. And math dot power. Math dot power, right? This is the worst possible way of using it, by the way. You can actually do whatever it is, P1 times P1, right? Okay, and we're going to do the x2 minus x1, right? x2 minus x1 inside this power, right? So we're going to say, in the first one, we're going to say P2 dot x minus P1 dot x, right? Comma to the power of 2, right? Plus math dot power, right? P2 dot y minus P1 dot y to the power of 2. All in one line, guys. So I'm saying, hey, if the square root of the points, the difference between the first point and the second point, right? This part. So this part right here, from here to here, this is the distance formula that I could call a distance formula instead of using this. If this, I'm going to put another bracket over here. If this is less than, I'm going to put it on a new line now, because we're going to carry on, is less than each object, right? Half the height of each object, because we're going this way. Okay, could be half the width, but half the height might be okay, right? Half height. We already have half height, so we're going to say plane less than plane dot half height. Oh man, this dot plane dot half height. I prepared it. I knew I was going to need it, right? Plus other dot half height. I'll write this. And right, so if we take the square root of the distance, so the distance, here's the distance. This is the distance formula, right? And we say if the distance is less than the two half heights, the combined combination of two half heights, you have a collision. All right. Let's just say collision. How about that? So we'll say, of course, they're calling me at the wrong time. Console.log. We'll just say collision. Collision.
I have a question.
Yeah. Yeah.
So why are we doing that? Is it, wouldn't it be easier to have two different checks, one for horizontal and one for vertical?
Yes. Minimum viable product.
Yeah, but then that would be easier.
But then I'm doing two checks. Two checks every frame.
Wouldn't that be easier than having square root?
No, but then if you did the difference in, you're talking about bounding boxes again, right?
So which one are we doing?
We're doing distance.
So circle.
Yeah, radius. Radius. Because so we're saying here's the radius, but really we're just using one part of it, because we could use the height or the width. It's actually not a real circle. It's just the radius, just the height. Huh? Yeah, but it's for now it's not even that. It's half the height, right? Because if for the cloud it's not accurate, because the cloud is this way, it's wider than it is this way, right? So it would be an ellipse later on for now, but we're not going to do that. Or some people call it a capsule collider, right? Anyway, so we're saying it's a collision. We don't know who collided yet, but we can find out collision with, and then the name of the object that's colliding, right? Plus other dot name. Collision with island or cloud, right? Whatever that is. Remember, we set that whole name thing up already. Let's check this out and see if it works. So go back to here. Looks like it's working. Run it, and oh man. Oh wait, we didn't actually put it into being. We didn't actually check collisions. We need to check collisions every frame, which is every update. All right, so when do we check collisions? We update the plane, we update the ocean, we update the island, we update the clouds, and then we check collision. Right here. We'll say this dot underscore check collision. We'll check collision, right, every frame by passing in for the island, right? And I want to do the island right away. So let's say here's the island. So I change the island's position, and then I check collision for the island. So I pass in this dot underscore, or island, right? Notice how it takes it, because it's a game object, type of objects.game object, right? And then inside my update function, after my update, I check collision here. This dot underscore check collision, and pass in this dot what? Cloud, just cloud. Because this is a for each loop where we can pass in the cloud, which is also of type game object, right? So I can take either island or cloud because they're both game objects. That's why I set up the superclass, right? So it works. Otherwise, would not work. You'd have to set up two checks, right? Two different methods. Cool, now let's try it out. Start. So collision with island. Oh man, but it's like 20 collisions. Collision with clouds. Remember I talked about this? It works, the collision system works, right? But it collides way too much. So remember how we fix this? It only collides if the object is not colliding do we check for collisions? We don't even do this if statement here. So this is what this does is check that or compare the distance between point 1 and point 2 is less than half the height of the object. So this thing does. So before we even do this check, before we even go there and do this whole check right here, right? Which is nice, but unreasonable if we did it every single time, right? We only do it if P2, which is the other object, if the other object itself is not colliding. So we put this on the outside. We say if other dot is colliding, not is colliding, not is other colliding, then only if and only if that's true, right, are we going to do this. Okay. We talked about that is colliding as a Boolean. We can set it. Right now by default it's false, right? Cool. Well, okay, fine. So if it's not colliding, check to see if it is colliding. And if it is colliding, print it out and then set this to true. Set other dot is colliding, right, is equal to true, right? Because we just checked and it's colliding, right? All right, but what if it's not colliding? If not, the other is colliding, right? Then do this. However, if it is colliding, right, and if this collision check failed, right? Oh man. Is this right? This should be inside. So this should be over here. Hold on a second. I'll rejig everything. Reformat everything. Format selection. Why is that? Because we need to check. We need to do this check every time anyway, because there's no way of setting it the other way around. So saying if this is true, then the other is colliding is true because we went in here. Otherwise, if it's not true, then else other dot is colliding is equal to false. So we can check it again later. Okay. So again, what am I doing? I'm saying, hey, check to see the distance if it's less than half the heights. If it's true, also check to see if the other one is not colliding. If it's not colliding, then register a collision. If it is colliding, don't do anything, right? Else, if the square of the distance between the 2 points is not less than half the heights, then, well, the other's not colliding. So make sure it's false. Okay? Great. Simple stuff. Yeah. It's actually quite confusing to a lot of people, but I'm putting it up. Okay, this should fix us, right? This should make sure that the only time we register a collision is when we need to. And let's see if it works. So now one collision. See? 1, 1, 2 collision, 3, 4, 5. But it's not like thousands, right? We only collide one time, right? Unless, of course, I do something like that, where I kind of, want to do one of these, where I can try and register collisions as fast as I can, and by going back and forth. Then that's a problem. And it's a problem because I'm using my mouse to control my character, my avatar. It's better to use your keyboard or some kind of controller eventually, which gives you more control. All right? Yay, we have our collision system. And we know it works, right? So guess what we're going to do? We're going to update this, and we're going to take a short break. And when we come back, we're going to make the collision system work with the user interface. All right? Remember, we're working towards our minimum viable product, our first playable today. I want to try and get that done for me, for my mail pilot game, to show you how you would do it. All right, so these are all the changes I made. Add them to the staging area. I'm going to say added collision detection. Right, that's what I did. Push. Now, along the way, I had to add that extra game object. I had to add that abstract class, right? Because the abstract class helped us to determine that if it's one object or the other. Which one is it? And I can do one check to check both objects. I don't have to say check with island, check with cloud. Two different kinds of methods. Do the same exact thing. I'm going to do twice as many checks that way, right? And write two different methods that are exactly the same, but just can't identify one object over the other. Let's stop right now. When we come back, we'll do a user interface for our game.